tool in question is a combination tool designed for electrical work. It's manufactured by Klein Tools, a well-known brand in the electrical and construction industries. The specific functions of this tool are threefold. Firstly, it serves as an automatic wire stripper. Secondly, it functions as a wire cutter. And thirdly, it includes crimping jaws for terminating wires with connectors. Let's delve into each of these functions in more detail. The automatic wire stripping function is designed to remove the insulation from electrical wires without damaging the conductor. Automatic wire strippers typically have adjustable jaws that grip the wire and then pull the insulation away. The user inserts the wire into the stripping jaws and squeezes the handles. The tool then automatically grips the wire, scores the insulation, and pulls it off in one smooth motion. This type of stripper is particularly useful for repetitive stripping tasks, such as when wiring electrical panels or making multiple connections. The wire cutting function is accomplished via a hardened cutting blade located between the handles. This blade is designed to cleanly cut electrical wires of various gauges. The user simply places the wire between the cutting blades and squeezes the handles to sever the wire. The crimping function allows the user to attach connectors such as terminals, splices, or lugs to the ends of wires. The crimping jaws are located between the handles, usually near the pivot point. The jaws are designed to compress the connector around the wire, creating a secure and reliable electrical connection. Different sizes of crimping jaws are often provided to accommodate various sizes of connectors. When using the crimping function, it's important to select the correct size of crimping die for the connector being used. Using the wrong size die can result in a loose or unreliable connection, which can lead to electrical problems or even safety hazards. The K.Y.P. branding on the tool likely refers to the specific model or series of the Klein Tools wire stripper/cutter/crimper. Klein Tools often uses alphanumeric codes to identify their different products. To identify the tool model precisely, you can try these steps. Firstly, examine the tool closely for any other markings such as a model number or date code, which may be stamped or printed on the tool's body. Secondly, visit the Klein Tools website and browse their catalog of wire strippers, cutters, and crimpers. Compare the features and design of the tool to the model shown on the website to find a match. Thirdly, contact Klein Tools customer service and provide them with a description of the tool, including the K.Y.P. branding. They may be able to identify the tool model based on your description. Proper usage of the Klein Tools wire stripper/cutter/crimper is important for ensuring safe and reliable electrical connections. Here are some general guidelines. Firstly, always disconnect power to the circuit or equipment before working on electrical wiring. Secondly, select the correct stripping setting for the gauge of wire being used. Using the wrong setting can damage the conductor. Thirdly, when stripping wires, hold the tool perpendicular to the wire and apply even pressure. Avoid twisting or bending the wire, as this can weaken the conductor. Fourthly, when cutting wires, ensure that the cutting blades are sharp and clean. Dull or damaged blades can result in ragged cuts. Fifthly, when crimping connectors, use the correct size of crimping die for the connector being used. Over-crimping can damage the connector, while under-crimping can result in a loose connection. Sixthly, inspect all connections to ensure that they are secure and properly made. Pull gently on the wires to check for loose connections. Seventhly, follow all applicable electrical codes and safety regulations when working on electrical wiring. Always wear appropriate personal protective equipment, such as safety glasses and gloves. Understanding wire gauges is critical for using wire strippers and crimpers effectively. Wire gauge refers to the diameter of the wire conductor and is typically measured using the American wire gauge or AWG system. The AWG system is an inverse scale, meaning that a smaller number indicates a larger diameter wire. For example, 12 AWG wire is larger than 14 AWG wire. Different wire gauges are used for different applications, depending on the amount of current the wire needs to carry. Larger gauge wires are capable of carrying more current than smaller gauge wires. When using a wire stripper, it's important to select the correct stripping setting for the gauge of wire being used. Most wire strippers have adjustable settings that allow the user to match the stripping diameter to the wire gauge. Using the wrong setting can either damage the conductor by stripping too much insulation or fail to remove enough insulation, resulting in a poor connection. Common wire gauges used in residential wiring include 12 AWG and 14 AWG for general lighting and receptacle circuits, and 10 AWG for larger appliances such as electric ranges and dryers. In commercial and industrial wiring, larger gauge wires such as 8 AWG, 6 AWG, and 4 AWG are often used for high current applications. The National Electrical Code, or NEC, provides guidelines for selecting the appropriate wire gauge for different applications. The NEC specifies the maximum allowable current carrying capacity, or ampacity, for different wire gauges and insulation types. It's important to consult the NEC and follow its guidelines when selecting wire gauges for electrical wiring. Color coding of wires is another important aspect of electrical wiring. In North America, wires are typically color-coded to indicate their function within a circuit. The most common color codes are black for hot wires, white for neutral wires, and green or bare copper for ground wires. Hot wires carry electrical current from the power source to the load, such as a light fixture or appliance. Neutral wires provide a return path for the current back to the power source. Ground wires provide a safety path for current to flow in the event of a fault, such as a short circuit. Following color codes is essential for ensuring safe and correct wiring. Incorrect wiring can lead to electrical hazards, such as shocks, fires, and equipment damage. When working on electrical wiring, it's important to identify the different wires by their color codes and connect them to the correct terminals or devices. If you're unsure about the wiring, consult a qualified electrician. Electrical safety is paramount when working with electrical wiring and equipment. Electricity can be dangerous, and even a small shock can be fatal. It's important to take precautions to protect yourself from electrical hazards. Firstly, always disconnect power to the circuit or equipment before working on electrical wiring. Use a circuit tester to verify that the power is off. Secondly, wear appropriate personal protective equipment such as safety glasses, gloves, and insulated shoes. Avoid wearing jewelry or other conductive items that could come into contact with electricity. Thirdly, work in a dry environment. Avoid working in wet or damp conditions, as water can conduct electricity. Fourthly, use insulated tools that are designed for electrical work. Avoid using tools with damage to worn insulation. Fifthly, never touch bare wires or terminals. Always assume that wires are energized unless you have verified that the power is off. Sixthly, if you're unsure about any aspect of electrical work, consult a qualified electrician. Don't attempt to do work that you're not comfortable with or don't understand. Seventhly, follow all applicable electrical codes and safety regulations. The NEC provides guidelines for safe electrical practices. Proper grounding is another important aspect of electrical safety. Grounding provides a low resistance path for current to flow in the event of a fault, helping to protect people and equipment from electrical shock. The electrical systems are typically grounded by connecting the neutral wire to a grounding electrode, such as a ground rod or metal water pipe. The grounding electrode is buried in the earth and provides a connection to ground. Grounding also helps to stabilize the voltage in the electrical system and reduce electrical noise. Proper grounding is essential for ensuring the safe and reliable operation of electrical equipment. Electrical bonding is another important concept in electrical safety. Bonding refers to the practice of connecting all metal parts of an electrical system together to create a continuous electrical path. This includes metal conduits, enclosures, and equipment housings. Bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. In the event of a fault, bonding provides a low-resistance path for current to flow back to the power source, tripping the circuit breaker or fuse and de-energizing the circuit. Electrical testing is an important part of electrical work. Testing helps to verify that electrical circuits are working properly and that they are safe to operate. Common electrical tests include voltage testing, continuity testing, and insulation resistance testing. Voltage testing involves measuring the voltage between different points in a circuit to verify that the correct voltage is present. Continuity testing involves checking for a continuous electrical path between 2 points in a circuit. Insulation resistance testing involves measuring the resistance of the insulation surrounding electrical conductors to verify that the insulation is intact and not leaking current. Electrical troubleshooting is the process of identifying and resolving problems in electrical circuits. Troubleshooting often involves using a multimeter or other testing equipment to diagnose the cause of the problem. Common electrical problems include open circuits, short circuits, ground faults, and voltage drops. When troubleshooting electrical problems, it's important to follow a systematic approach. Firstly, gather information about the problem. Secondly, inspect the circuit for obvious signs of damage or loose connections. Thirdly, use a multimeter or other testing equipment to test the circuit and identify the source of the problem. Fourthly, repair the problem and test the circuit to verify that it is working properly. The National Electrical Code, or NEC, is a set of standards for safe electrical installation and wiring. The NEC is updated every 3 years and provides guidelines for all aspects of electrical work, from wiring methods to overcurrent protection to grounding. The NEC is widely adopted in the United States and is used by electricians, inspectors, and other electrical professionals. It's important to consult the NEC and follow its guidelines when performing electrical work. Understanding electrical schematics is important for understanding and troubleshooting electrical circuits. An electrical schematic is a diagram that uses symbols to represent the components and connections in an electrical circuit. Schematics can be used to trace the flow of current through a circuit and to identify the function of different components. Common schematic symbols include resistors, capacitors, inductors, diodes, transistors, and integrated circuits. Electricians and other electrical professionals use schematics to design, install, and troubleshoot electrical circuits. Electrical permits are required for many types of electrical work. Permits are issued by local government agencies and are intended to ensure that electrical work is performed safely and in accordance with applicable codes. Electrical inspections are performed by government inspectors to verify that electrical work has been performed correctly and that it meets code requirements. Permits and inspections help to ensure the safety of electrical systems and to protect the public from electrical hazards. When working with the Klein tools wire stripper/cutter/crimper, consider the specific type of wire you're working with. Solid wire is a single strand of metal, while stranded wire consists of multiple smaller strands twisted together. Stranded wire is more flexible and resistant to breakage than solid wire, making it suitable for applications where the wire will be subject to bending or vibration. When stripping stranded wire, it's important to use a wire stripper that is designed for stranded wire. These strippers have jaws that are designed to grip the individual strands of wire without cutting or damaging them. When crimping connectors onto stranded wire, it's important to use a crimping tool that is designed for stranded wire. These tools have crimping dies that are designed to compress the strands of wire together to create a secure connection. Aluminum wire is sometimes used in electrical wiring, particularly in older homes. Aluminum wire is lighter and less expensive than copper wire, but it also has some drawbacks. Aluminum wire is more prone to corrosion and oxidation than copper wire, which can lead to loose connections and electrical problems. Aluminum wire also expands and contracts more than copper wire with changes in temperature, which can also contribute to loose connections. If you have aluminum wiring in your home, it's important to have it inspected by a qualified electrician. The electrician can inspect the connections for signs of corrosion or looseness and make recommendations for repairs or replacements. One common solution for aluminum wiring is to use copper pigtails to connect the aluminum wire to copper devices. This involves attaching a short length of copper wire to the aluminum wire using a special connector that is designed for aluminum to copper connections. The copper pigtail can then be connected to the copper device using a standard wire connector. Electrical boxes are used to enclose electrical connections and protect them from damage and the environment. Electrical boxes are typically made of metal or plastic and are available in a variety of sizes and shapes. The size and type of electrical box required for a particular application depends on the number and size of wires and devices that will be installed in the box. Electrical boxes must be installed in accordance with the NEC and must be properly grounded. Wire connectors are used to join two or more wires together. There are many different types of wire connectors available, including wire nuts, push-in connectors, and terminal blocks. Wire nuts are the most common type of wire connector and are used to twist wires together and secure them with a plastic cap. Push-in connectors are a newer type of wire connector that allows wires to be connected simply by pushing them into the connector. Terminal blocks are used to connect wires to electrical devices, such as switches and receptacles. When selecting wire connectors, it's important to choose the correct size and type for the wires being connected. It's also important to ensure that the connectors are properly installed and tightened to prevent loose connections. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Circuit breakers are reusable devices that trip and open the circuit when an overcurrent is detected. Fuses are one-time devices that melt and open the circuit when an overcurrent is detected. The size of the circuit breaker or fuse required for a particular circuit depends on the ampacity of the wires in the circuit and the load connected to the circuit. Overcurrent protection devices must be installed in accordance with the NEC. GFCI protection, or ground fault circuit interrupter protection, is required in many areas of the home, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. A ground fault occurs when current leaks from a hot wire to ground. GFCIs can detect ground faults as small as 5 mA and can trip the circuit in a fraction of a second. A size or arc fault circuit interrupters are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a spark or arc. A size can detect arcing faults and trip the circuit, preventing a fire from starting. A size are required in many areas of the home, such as bedrooms and living rooms. Electrical lighting is an important part of any building. There are many different types of lighting available, including incandescent, fluorescent, LED, and halogen. LED lighting is becoming increasingly popular due to its energy efficiency and long lifespan. When selecting lighting, it's important to consider the amount of light required, the color of the light, and the energy efficiency of the lighting. Smart home technology is becoming increasingly popular. Smart home devices can be controlled remotely using a smartphone or other device. Examples of smart home devices include smart lighting, smart thermostats, smart security systems, and smart appliances. Smart home technology can improve convenience, comfort, and energy efficiency. The Klein tool's automatic wire stripper/cutter/crimper is a versatile tool that can be used for a variety of electrical tasks. By understanding the functions of the tool and following proper safety procedures, you can use it to make safe and reliable electrical connections. Always consult with a qualified electrician if you have any questions or concerns about electrical work. Always refer to the latest edition of the National Electrical Code, specifically Article 310.15, formerly 310.5 for ampacity correction factors and derating. It's crucial to understand ambient temperature correction factors, as conductor ampacity is typically rated at 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature exceeds this, you must derate the conductor ampacity. For example, if a conductor has an ampacity of 30 amps at 30 degrees Celsius and the ambient temperature is 40 degrees Celsius, you would need to apply a correction factor, which would reduce the allowable ampacity. Also, consider conduit fill. NEC dictates the maximum percentage of conduit space that can be occupied by conductors. This is to ensure proper heat dissipation and prevent overheating. Exceeding the allowable conduit fill can lead to derating of conductor ampacity. For instance, if you have more than 3 current-carrying conductors in a conduit, you will likely need to derate the ampacity. This information can be found in NEC Table 310.15 cone. Regarding voltage drop, it's essential to calculate voltage drop in circuits, especially in long ones. Excessive voltage drop can cause equipment to malfunction. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders. There are formulas and calculators available to help you determine voltage drop based on wire size, current, and distance. When choosing conductors, insulation type is a critical factor. Common insulation types include THHN, THWN, THW, and XHHW. Each insulation type has different temperature ratings and suitability for wet or dry locations. For example, THHN is suitable for dry locations, while THWN is suitable for wet locations. Refer to NEC Table 310.104 for conductor applications and insulations. Finally, always ensure proper grounding and bonding. Grounding provides a path for fault current to return to the source, tripping the overcurrent protection device. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electric shock. Consult NEC Article 250 for grounding and bonding requirements. Proper grounding and bonding are essential for electrical safety.